In this video, we're going to talk about understanding the research process, specifically methods of studying the flipped physics class. And this presentation is brought to you by Corey Larrison. Now, the flipped classroom is very straightforward. Lectures are presented as videos to be watched at home, and class time is used for students to work on practice problems and hands-on activities, hence flipping the traditional class, where you would get lectures in class and do homework and hands-on stuff at home. Now, this is a very popular pedagogy for AP Sciences. I myself use this in my AP Physics class. If you go to YouTube, there are tons of flipped classroom resources. There's this content by A Plus Physics, this content from Flipped Physics, this content from the Organic Chemistry Tutor, but they're teaching physics, and then Professor Dave explains in his physics. Bozeman Science has a thing on physics, and of course MIT is just uploading all of their content to the internet in hopes that the AI sometime becomes self-aware and can just make all of this content itself. Now, we're going to look at two studies on the flipped physics classroom. One is a quantitative study by Kagande and Hugar titled The Flipped Classroom and College Physics Students' Motivation and Understanding of Kinematic Graphs. This study was done in 2018. A qualitative study done in 2017 by Susan Ramlow is titled Student Views Regarding Online Freshman Physics Courses. So let's dive into the quantitative piece. The question that this study is trying to answer is, does the flipped class affect student comprehension of kinematic graphs? Now, it also simultaneously tries to answer the question, does the flipped class affect students' motivation to learn physics? The setting for this is the Philippines, in a course called College Physics 1, which is a freshman level, college level course. And they flipped two sections with a total of 85 students, and then two sections were held as control groups with a total of 70 students. It's kind of funny, the study says that they casted lots to decide who was flipped and who was controlled. Now, one unit was flipped, so this study encompasses 8 total lessons and is relatively small in its scope. The method is very straightforward. They use a Solomon 4-group design, which means they administer pre-test and post-tests, but they only give the pre-tests to 2 of the groups, one experimental, one control. Everybody takes the post-test. Now, what they use for their pre-test and post-test for understanding kinematic graphs is the test for understanding kinematic graphs, or the TUG-K, which is a well-known instrument in physics education research. The other test that they use for motivation is Test for Physics Motivation Questionnaire 2, or the PMQ2. Again, this is a well-known instrument in physics education research. Now, their actual study is basically an independent t-test of pre-tests to compare the experimental and control, and to make sure that there were no outliers, any outstanding courses that from the pre-test showed that they already knew a bunch of information. Then they did a paired t-test of the gains to compare the experimental and control groups. Of course, this is only for the 2 groups that took both the pre-test and the post-test. Then they did an independent t-test of post-tests to, again, try and find an outlier to ensure that there wasn't one group that got some sort of outstanding lesson or cheated, and thus threw off all the results. Speaking of the results, when asking the question, does the flipped class affect student comprehension of kinematic graphs, they said that the TUG-K gains were significantly higher for the experimental group with a mean of 1.87 and a standard deviation of 2.9, when compared to the control group of mean 0.54 and a standard deviation of 1.8. So, yes. Does the flipped class affect student motivation to learn? Well, this one was a little murky. They didn't find any significant difference, and so they just kind of let it lay flat. Now on to the qualitative piece. The question for the qualitative study by Susan Ramlow was, how do students who are currently enrolled in a flipped physics class view the potential of their class being taught fully online? So she surveyed students who were in a flipped physics class and basically asked them, do you think that this course could be taught fully online without the face-to-face component? The background is that there was a little bit of pressure from the administration to make a fully online physics course, so she thought that it would be a good idea to ask people that were in a blended environment about whether or not a fully virtual online environment would be beneficial. So the setting is a large Midwestern university and a freshman physics course, so freshman physics students who were non-majors, so these were not physics majors. In total, there were 47 students. And the method of this research is kind of interesting. She used something called a Q methodology, which is identified as a mixed method. Now, the Q methodology is, ish. It's qualitative-ish because they're going to try and take qualitative statements from students and turn it into some sort of quantifiable metric. So to do this, they take what's called a Q sample. So 45 statements in this study were created from interviews with students and also administrators. Then these statements about online courses were sorted by the 47 students into something called a Q sort. Now the Q sort is basically like a questionnaire where you're asked, does this statement align with your view or is it unlike your view? But students are forced to put all 45 statements into one of these boxes. So they can't just make everything a 5 or a -5 or a 0. They have to put something in this spectrum. And ideally that there will be some sort of pattern that emerges with statements that can be grouped together. So to do that, they get these things that they call unique factors that emerge from analysis by a program called PQ method. These factors are supposed to indicate what the students view as a group. It's sort of like the hive mind emerging. So the results, there were 3 factors. Factor 1 was that students prefer keeping the class real and face-to-face. Factor 2 was that students think they could be successful online, but only if they had a good instructor. And factor 3 was that STEM classes in general should not be online courses, which that's just, I mean, come on, that's hilarious. Susan, what are you trying to do here? Okay, so mostly negative views. Now, not negative views about the flipped classroom, but negative views about whether the flipped classroom could transition into an online, fully online thing. You know, can it lose the face-to-face aspect? Now, when comparing these two studies, I see a lot of similarities. Number one, they're both empirical studies. They're trying to use raw observation. They're very science-minded. There isn't a lot of emphasis on like critical theories or certain social programs. It's kind of cut and dry. Now, the other thing that they have in common is that they both include intimate sample sizes. So no one has over 100 participants or data points in this study, and that's pretty low. So it's a very localized study in each case. The other thing that I think they have in common is a positive bias towards the flipped classroom. So on the one hand, the Kagande and Hugar piece is seemingly trying to prove what it sees as a new and effective method. The literature review is very positive and flattering of flipped classrooms. And similarly, Ramelow is pretty clearly trying to say that the flipped classroom needs the face-to-face element and is therefore assuming that this is an effective method of instruction, which that is explicitly stated in the literature review when they talk about the flipped classroom, and she references studies much like Kagande and Hugar that are showing pre-test, post-test gains. Now, the other thing that these have in common is educational policy implications. Kagande and Hugar are talking about certain reforms that are happening in the Philippine educational systems, and that they want to include technology as a part of those reforms, and that this is going to be one of the things that does it, the flipped classroom. Ramelow has a different educational policy implication. She's trying to dissuade administrations from using fully online physics courses, which again, change is trying to come from these studies. The other thing that they have in common is really, when you look at it, they're both kind of mixed methods. The quantitative study is quantitative, but by using a motivation questionnaire, it is pretty mixed. So it's kind of quantitative, but ish. So they're both ish, quantish and qualish. Now, what are the differences between these ishes? Well, the first is certainly that the Kagande piece is much more quantitative. They are using student pre-test, post-test gains, statistical analysis that's very straightforward and well-known. So it definitely leans more on the quantitative side, whereas the Ramelow piece is more qualitative. By taking student statements from interviews, they're definitely getting a lot more qualitative responses out of this. The other thing that they differ in is their instrument. So the quantitative piece is using pre-tests and post-tests to measure these things, as well as the motivation questionnaire. The Ramelow piece is a little bit different. Eventually they get to a questionnaire that could be similar to the motivation questionnaire, but they come up with these questions from direct interviews with students and administrators. So that's going to take a lot more time and effort, and it really changes the nature of the study process. The other thing that they differ in is the method of analysis. So for the quantitative study, it's just straightforward SPS, statistical analysis, t-tests, and for the qualitative method, this PQ method, which is a bit more mixed and experimental, is being used to create factors, which are much different from just raw statistical methods. Okay, the other way that they differ is that the quantitative piece is affirming the flipped class through positive results. They're trying to show that this is an effective mode of instruction based off of gains from pre-test to post-test. The Ramla piece is not doing that, but it is still affirming the flipped class. However, it's doing so through negative results, specifically negative results in the views of students on whether or not the flipped class could lose its face-to-face element. So again, it's coming from a different perspective, but it is still affirming the flipped class, which goes back to that bias that they both share in common. Now, the other way that they differ is the quantitative piece is certainly narrow in its scope. It's 1 unit, 8 lessons, very straightforward. Whereas this qualitative study is very broad. It is taking place during a semester, and the questions and statements are not specific to that semester. Instead, they involve the students and the administrators' entire experiences, both with the flipped classroom and with physics, and STEM courses in general. So it is much harder to define what it is that they are studying, and like, where is it in its time and place. Now, hopefully this was an informative discussion of the research process for these two studies, and that eventually MIT will be able to ingest this video and create better courseware for its students much later. Thank you, AI.